The upper half of an inclined plane of inclination theta is perfectly smooth while lower half is rough. We need to find at what value of the coefficient of friction between the block and the lower half of the plane, a block starting from rest at the top of the plane will again come to rest at the bottom. Let's understand this through the figure. The block starts from the rest at the top of the plane and comes to rest at the bottom. And for this to happen, the work done by friction on the lower half must exactly cancel out the gravitational potential energy gained by the block as it moves down the smoother upper half. As the block moves down the smooth upper half, it gains kinetic energy due to gravity. When it reaches the lower half, this kinetic energy will be converted to work done against friction until the block comes to rest at the bottom. Let M be the mass of the block, G the acceleration due to gravity, L total length of the incline, and theta be the angle of inclination. Let's find the height of the inclination. By using Pythagorean theorem, we get height of the inclination h is equal to L sine theta. The gravitational potential energy lost by the block as it descends the entire incline, we get potential energy mgh is equal to mg, h is nothing but L sine theta. Let's find the work done by friction on the lower half. Work done is nothing but frictional force into the distance. So let's first find out frictional force on the rough lower half. That is nothing but F is equal to mu into N. N is nothing but the normal force and it can be written as mg cos theta. The work done by friction over the lower half of the plane is F into L by 2, which is nothing but mu mg cos theta into L by 2. Setting up the equation for the block to come to rest at the bottom, the work done by friction on the lower half must be equal to the initial potential energy. Hence, upon substituting, we get mu mg cos theta L by 2 is equal to mg L sin theta. On simplifying, mg cancels out, L and L cancels out. Hence, we get mu cos theta is equal to 2 sin theta. And solving for mu, we get 2 sin theta by cos theta is equal to 2 tan theta. Hence, the right option is option B, mu is equal to 2 tan theta.